Okay, so we're going to talk about, start talking about transformations, and this is 1.3. It's an introduction to them, and it's on page 31. So a transformation is a function that changes the position, shape, and or size of a figure. The input of a transformation is the preimage, and the output is the image. And those are all vocabulary words, by the way. You can use prime notation to name the image. And see here, we have our point, A, and then we move it, we call it A prime. Now, before I get into these examples, let's talk about transformations. So, transformations, we have translations, and that is 2.1. We have reflections, which is 2.2 or 2.3, I'm not sure. We have rotations, which is the other one in Module 2. And the fourth one is a dilation. Now, we won't talk about dilations in Module 2 at all. This is just introducing them, and then we will talk about them later on, maybe about a month from now. So a translation is a slide. You're sliding the figure to somewhere else on the graph. A reflection is a flip, and a rotation is a turn. So you're sliding, flipping, turning. Now, a dilation will change the size. And it is the only transformation that actually changes the size. So these guys, because they do not change the size of a figure, we call them, they have what we call rigid motion. Okay, you just pick it up and you're setting it somewhere else, but it doesn't change size. And that's a huge concept in geometry, rigid motion is. So if we look at this first example, this is going to be a translation. And if we look at this notation up here, xy goes to x minus 4, y minus 3. So what you're doing is you're subtracting 4 from every x, and you're subtracting 3 from every y. So if you look at this shape over here, A starts at 0, 4. We subtract 4 from the x and 3 from the y, and we end up at 1, 2, 3, 4, 1. So here is my A prime. B is at 3, 0. And we subtract 4 from the x and 3 from the y. So I go negative 1, 1, 2, 3. There's my B prime. And C is at 0, 0, so we end up at negative 4, negative 3. And there's my C prime. So you can see that this shape did not change size. It just slid to the left and down. And that's what a translation does. Okay, so the next 32. This says xy goes to, and I'm not going to say negative x, I'm going to say opposite. X, y. And this is a reflection. So you can see that this would become 4, 3, 1, 3, and 4, 1. And if we plotted those points, we would get this. And you can see that this was reflected over the y-axis, right? Do you see that? It was flipped. C, anytime you're multiplying x or y by something, it's going to be a dilation. It's going to change the shape. And that is not rigid motion. And actually, this isn't even a dilation, because a dilation has to change, it has to change size the same in every direction. So a dilation would have to actually look like that. Let's see, next page. Rigid motion, here's your definition. Rigid motion is a transformation that changes the position of a figure without changing the size or shape. Okay, and you can see here, rigid motion preserves distance, angle measure, betweenness, collinearity, and parallelism. And we will talk more about those. Remind me if I forget when I see you the next time. Let's see. Let's go to page 35. It says, write the rule that maps each pre-image to its image. So, x, y goes to, and what's happening here between the x's and the y's, and it's kind of hard to tell with the D, point D, because it's the same number for x and y. But if you look at E, can you see that it becomes opposite x, opposite y? And that works for all of them. So that's our rule. Now, if you look at 6, it gets a little bit more complicated. But can you see what is happening between them? You're adding 1 to the x, and you are subtracting 2 from the y's. And that is a translation. And that's all I'm really going to talk about with 1.3 now. We'll go over the homework. When you have questions with the homework, I'll hit the rest of it. But that's all I got.